We're often asked about the possibility of using TiTAN in agriculture. Today we will show one of the options for using TiTAN as a greenhouse management system. We will be able to control ventilation of a greenhouse depending on humidity and temperature of the air, to water according to a schedule or reduction of soil moisture, and to calculate how much water we have used. The system will be powered by a small battery and its charge will be replenished by a solar battery. First, we will make a soil moisture sensor. To do this, we will need a capacitive soil moisture sensor, the TiTAN board, a PCB antenna at 433 MHz, two AAA batteries, and a 3D printed case. The soil moisture sensor is designed to work at 5 volts. We will make a small modification and enable it to work on batteries. To do this, replace the stabilizer with a jumper. Let's put everything together and see what we've got. From our page titan-project.com/software, download the archive titan-greenhouse.zip and upload the project titan-low-csms to TiTAN. The program demonstrates the use of a power management mechanism and the sleep mode. Waking up every 5 seconds, the soil moisture is measured and the results are transmitted by the radio. This power supply system allows the sensor to work from 5 to 7 months. If you reduce the frequency of the measurements, the sensor can work for up to 1 year on one set of batteries. Let's put the sensor in the greenhouse. Next, we will assemble a controller that will be located in the greenhouse to receive data from the sensor, measure the temperature and humidity of the air, control motors and fans on the windows, open the water supply valve for watering, and count the water flow. To do this, we will need the TiTAN board, a DHT22 or an AM2302 temperature and humidity sensor, 5 miniature relays, relay control keys, and electronic skills for assembling a 3.3 volts pulse stabilizer. Here's what we've got. Let's upload the project TiTAN CSMS2 to TiTAN. You can find the port assignment in the project settings. The controller will be powered by a special solar battery control device. We will place them both along with the battery inside the greenhouse. Do not forget about the antenna. We will place the solar panel on the roof and connect it. Now you need to install the window opening closing motors and the fans. It should look like this. Install the watering system, the water supply valve and the water flow sensor. Lay a hose with micro-irrigation on the beds of the greenhouse. After that, connect everything and start assembling the control panel. To do this, you will need the TiTAN board, Nexion 2.8 inches smart display, and the 3D printed case. Let's upload the project TiTAN CSMI3 to the TiTAN and the project greenhouse.hmi to the Nexion display. Here's what we've got. We can see that the data from the greenhouse is already being received by the radio. The air temperature in the greenhouse is 47 degrees Celsius, the humidity in the greenhouse is 24%, and the soil humidity is quite low. The windows are closed, the fans are turned off, the watering system is also turned off, the water consumption is 0. Now let's see how it all works. You can easily adjust the air temperature at which you need the ventilation to start. You can control the soil moisture according to your requirement, as well as configure the time of the watering and the time of the automatic opening and closing of the windows.